Hello, everybody, and welcome to week 11 of Math 1220 online. Before I get started, let me just apologize. These slides the handwriting's maybe a little bit worse than normal. I sprained my wrist, so sorry about that, but hopefully you can still read them. And the big announcement, of course, that the second exam is next week. So that's week 12, March 27 to 31st. Do go ahead and get that scheduled now in the schedule exam section, where it's just like the first exam where you take in the proctoring center. But do go ahead and get that scheduled earlier rather than later, just to make sure you can get a good time slot that works well for you. The exam is on sections 8.1 to 8.4 and 9.1 to 9.7. This is all of the stuff we've been doing. That's web work and written assignments 5 through 8. This is all of the stuff we've been doing starting the week after exam 1 and going up through this week. So assignment 8 is this week. So that's like stuff like this L'Hopital's rule, improper integrals, sequences and series. And then this week, we're doing sections 9.6 and 9.7, which are on power series. I'll say a little bit more about that in a moment. Just like the first exam, there's a web page with information and resources, including practice exams. So if you scroll down to week 12, you'll see this link here. And if you click on this, this will get you access to all that information. You'll get to preview the formula sheet and so on. So do go ahead and look at that. The rules for the exam, the format, the practice, they're just like exam 1. In particular, do take the practice exam to prepare. I encourage you to study first, study a bit first, then take the practice exam as if, so set yourself up as if you were taking the exam. Take that practice exam, see how you do on it, see what areas you need to strengthen, and then study on those areas before taking the actual exam. So get started early and leave yourself enough time to do that. Good, and otherwise sort of it's just like exam 1. So hopefully now that you've sort of done one exam in this proctoring center, you sort of know roughly how things go. You have a little bit firmer expectations and can prepare better going into it. And maybe just as a reminder on that note, even if you didn't perform as well as you'd like to on your first midterm, as I announced afterwards when I posted the grades, for your final exam grade will replace your lowest midterm grade, at least if that helps you. So you have a lot of incentive to do well on this midterm. If you do well on this midterm and you do well on the final exam, then your first midterm essentially goes away. So it's worth taking the time to prepare and study well for this one. Well, it's always worth taking that time, but maybe somehow game theoretically, it's particularly worth that time with this setup. Just one note about office hours, if you want to use those at all to help you prepare. My regular office hours are this Thursday. That's March 23rd at the regular time, 1:10 to 2:50. And then the exam week office hours, just like the earlier exam week, they happen the Saturday before the exam week. So that'll be on Saturday, March 25th from 1 o'clock to 3 o'clock. In particular, there are no office hours on the Thursday of exam week, 3:30. So on exam weeks, I always do the office hours the Saturday before to give everyone a chance to come to office hours before they're scheduled to take the exam if they'd like to. Okay, good. But anyway, I encourage you to come stop by or send me an email if you have any questions, any concepts you want to brush up on, anything that comes up when you take the practice exam or so on. I'll be available. Great. Okay, so that's everything for the exam. Good. And then, so what are we doing this week? Well, we're doing sections 9.6 to 9.7. This is on the topic of power series. And so previously we were studying infinite sums, so infinite series, and we're asking like if I had sort of some list of numbers, it's an infinite list of numbers, like when can I add them all up and get something that really makes sense? There's sort of a couple of particular cases where we're actually able to give formulas for the result we got. And one of the key ones was sort of a geometric series. So we had like a series of 1 plus x squared plus x cubed and so on, where the absolute value of x was at most 1. Then we saw that converged, so that sort of gave that infinite series, it converged, and sort of moreover, we were actually able to figure out what value we got, and that converged to 1 over 1 minus x. So that's the value of this sort of infinite series. And if you look at that, well, if you just think of like one value of x, like if x is like a half, then sort of you get like the sum of 1 plus a half plus a quarter plus an eighth plus a 16th and so on. That gives you 1 over 1 minus a half, which if you sort that out, that's 2. So that sort of gives you something interesting if you plug in a specific value of x. We can also think of this actually as a function that takes in a value of x and then outputs something. And so like here it is described as a power series, so an infinite series with a variable. That's what a power series is. So some of our terms are expressed in terms of a variable x, and we're sort of plugging in values for x. And so the cool thing is like this sort of infinite series, when I plug in value of x, it gives me like this function I can describe in this different way, which is the function 1 over 1 minus x. Well, not for every value of x. Like if I plug in x equals 5, this left-hand side still makes sense, but this right-hand side doesn't make sense anymore. This doesn't converge if x is equal to 5. But so at least this works when the absolute value of x is less than 1. So I have this function 1 over 1 minus x, which can be described in the region where the absolute value of x is less than 1, using this infinite series where now sort of the terms sort of use that variable x. And this is sort of a cool thing, and this is basically what we want to study this week, is sort of if I have like one of these infinite series with a variable, or I like to think of them as being sort of like an infinite degree polynomial. So I'm going to sort of put like some coefficients in front of like the x and a coefficient in front of x squared and coefficient in front of x cubed and so on. Then I want to know like which of these infinite degree polynomials or power series define functions, like functions of the variable, and sort of for what values of x do they define those functions? That sort of what we call the radius of convergence of a power series. So that's what we're really studying this week. This week, we're really just doing the basics of this. So we're sort of going to have some like infinite degree polynomials or power series, and we're going to see like some tools for studying when like what values of x you can plug in and sort of get a function from that. So when those converge. And that's the big thing we want to get to this week, but this is going to have applications starting the week after the exam to calculus. And they're actually really cool because like, what's the great thing about polynomials? Well, for us, the great thing about polynomials is like, it's really easy to do calculus of polynomials. It's really easy to integrate a polynomial, and it's really easy to differentiate a polynomial. And sort of what you can hope is like, well, if I have like sort of this power series or infinite degree polynomial, like it should be just as easy to integrate that or differentiate that. I mean, somehow I should be able to do it like term by term. So I'd integrate like here, I'd integrate wanting it, like if I wanted to differentiate 1 over 1 minus x, like maybe I could just differentiate this term by term. So I'd get 0 plus 1 plus 2x plus 3x squared and so on. And the crazy thing is that really works actually. So somehow I sort of reduce like integrating or differentiating this complicated function to sort of just doing something that looks like differentiating or integrating a polynomial at the price of sort of my polynomial having infinite degree. So this is sort of particularly powerful if we can sort of express lots of different functions using sort of these infinite degree polynomials. And it turns out sort of many functions can be expressed this way, in particular important functions we encounter in calculus. And so we'll spend some time, that's what we're going to do after exam, is sort of see like how we go from a function we're interested in, sort of writing it as an infinite degree polynomial, and then we could sort of use that to do calculus with it. So I wrote here just a few examples that we'll see, and again, we're not going to see these until the week after the exam, when we study something called Taylor series. But for example, like the function ln of 1 plus x has this series, this sort of infinite degree polynomial or power series expansion, x minus x squared over 2 plus x cubed over 3 minus x to the 4 over 4 and so on. I wrote that with sigma notation right here. Or like e to the x has a power series expansion 1 plus x squared over 2 plus x cubed over 6 and so on, where sort of the nth term is x to the n over n factorial. So somehow like these functions that sort of from other optics can sort of look complicated, you can understand them sort of using these infinite degree polynomials. But again, this is something we'll see more after the break. So not after the break, but after the exam, the second exam, so that week 13. If you're sort of interested in this though, or sort of curious about this already, let me just say, like, I mean, sort of if you think about it, you can sort of deduce this identity ln of 1 plus x is equal to sort of this infinite series by sort of integrating this guy. So if you sort of integrate both sides of this, well, over here, I'm going to get ln of 1 minus x. Then I'm going to get something over here. And then I sort of just have to substitute x equals minus x. And that will sort of give you this identity. So, okay, this is a fun thing you can try if you're interested. Otherwise, just wait until after after the exam week, and then we'll come back to this idea in week 13. Okay, but anyway, enjoy the material this week. I think this is really cool stuff, actually, and it sets us up sort of for this even more interesting stuff. And good luck for the assignment, and start thinking about getting studying for the exam next week as well. Thanks.